All right, everybody, let's wrap up our discussion of correlations. We're talking about them in the context of hypothesis testing. So here's a scenario that I'm going to give us to kind of frame our context. Let's say that you become a researcher and you go into the realm of nutrition and you're very interested in the nutrition of children. So you ask this general question, something that you're curious about. Is candy consumption related to childhood depression? So you're wondering is if the amount of candy children are consuming, is that related to the rates of depression that we see children experience? So we got to take this general question and phrase it a little bit more specifically. So we want to phrase it in such that we say, is there a significant relationship between candy consumption and childhood depression? Here, the characteristics indicating a correlation is what we need to use. One, we have two variables being examined. Correlation only works with two variables. We've got two variables mentioned here. We're looking at the relationship between the variables. That's a key indicator for correlation. And then lastly, we see that, well, I didn't put it on the slide there, but we see that the variables would be continuous. You would know that from looking at the data set, from the context of your research. If you have two continuous variables and you want to know if they're related, you would use a correlation. Now, steps for the correlation test are the same 7 steps that you have been using for a long time now. They should be ingrained in your brain at this point. Now, with the correlation, the thing that's specific to it is the way you phrase the hypotheses, how you calculate the stat, the critical score you'll find. But after that, steps 5, 6, and 7 are all the same that it is for every other stat you've learned. So let's start with step 1. Let's look at the variables. So whatever variable is mentioned first in the question, which would be candy consumption, that's going to be our X variable. Now, candy consumption is continuous, and let's say that it was measured on a range of 0 to 10. So how many candy bars did they consume in the last week, ranging from 0 to 10 candy bars. Now, Y would be the second variable that's mentioned in the question. That's childhood depression. It's a continuous variable, and let's say that it's measured on a scale of 0 to 150. So you give them a questionnaire that measures depressive symptoms. And so 150 would be the highest, and it ranges in between there. So we want to know, is the variance, the variability for candy consumption, is that related to the variability of depressive symptoms that they're experiencing? So there we got our variables. And with that, we can then develop our hypotheses. Now with a correlation, because the correlation could be positive or negative, you can either have non-directional hypotheses or directional hypotheses. And that would be indicated in the question. So if the question simply asks, is there a relationship? It's non-directional. Therefore, your hypotheses are non-directional and two-tailed. So the alternative says says yes to the question. There is a significant relationship between your variables. And essentially what it's saying is that the R score will not equal 0. 0 means no relationship. So the alternative says, hey, the R score will be something else than 0. Now the null says no to the alternative. No relationship. There is no significant relationship between your variables. The null is essentially saying that the R score will equal 0. Now, what if your question is directional? What if it specifies the relationship? Is candy consumption significantly positively related to childhood depression? Or the question could say, is it significantly negatively related to childhood depression, right? It's not going to say both of them. It'll say one or the other. So the hypotheses are directional and will be one-tailed. So whatever the research question specified, the alternative says yes to that. So let's say the research question asked, is the candy consumption significantly positively related to childhood depression? The alternative says yes, it is positively related to childhood depression. So it's essentially saying that the R score will not equal 0 and will be a positive R score. Now the null has to say the two ways the alternative can't be true. Candy consumption can't be positively related to depression if it is negatively related or not related at all. So if the R score is different from 0 and is negative, then that's what the null is saying. Or the null is saying that the R score is 0. The relationship won't be positive or negative if it equals 0. So this is the template for how you would write your directional hypotheses if that was the case. Now, let's say for our scenario, we have 5 kids. We have Charlie, Augustus, Veruca, Mike, and Violet. And we study them after of them spending a week at a chocolate factory, and we counted up how many candy bars they ate during that week at the chocolate factory. And then after the week, we give them a depression questionnaire to see their level of depressive symptoms. So our research question here is there a significant relationship between candy consumption and childhood depression? Now you can see from the question that it's non-directional, so our hypotheses are going to be non-directional as well. So candy consumption, childhood depression are our variables. We have our hypotheses here shortened for the sake of space. And then we have our R-score, and we actually need to calculate that. So let's do that together right quick. Already got the elements there calculated for you. So go ahead and pause the video and plug in everything, find your covariance, and then use that to find your R-score. Now the numbers you should have gotten, the covariance is negative 30.5, and your R-score is negative 0.808. Now, that's not a coincidence that they're both negative. If the covariance is negative, the R-score will be negative. If the covariance is positive, the R-score will be positive. See, standardization does not change the direction of the relationship. It just changes the format of the number itself. But the direction stays the same. If it's negative, it's negative. If it's positive, it's positive. So now we have our R-score here, negative 0.808. And you can see that its strength by its R-score, coefficient of determination, is 0.652. So you could say that about 65% of their variances are overlapping here. So about 65% of being depressed is accounted for by how much candy they consumed in the last week. So what we need to ask now is how likely were we to find this relationship? If we assume the null is true, if we assume that candy consumption is not related to childhood depression, how likely were we to find this relationship? Was it likely or unlikely? Now we know that the probability of R, if it is less than 0.05, and finding the relationship is unlikely. So we need to do that workaround. We need to find that critical score, and we need to compare our calculated score to the critical score. And if it goes past the crit, it has a probability less than 0.05. So to do this, we need to locate the critical score on the R critical scores table. Make sure that you find that table. It's going to look very similar to the T table, and I don't want you to get confused on that. Make sure that you find the one that says R critical scores table, and it's going to look just like the one that you see on the screen here. So just make sure that you're paying close attention to that. Students have messed up by looking at the wrong table and putting the wrong crit, and then they can make the wrong comparison. So when you've got the right table in front of you, what you'll see is that you have two sides, the one-tailed side, the two-tailed side. You have two columns. You have three columns. The leftmost column is your degrees of freedom. That's going to help you find your row. And then the two right columns is the alpha level. We'll always use alpha as 0.05. That's going to help us find our crit score. Now, degrees of freedom is you simply take n, your sample size, minus 2. So with that in mind, go ahead and try to find the crit score. So we have a two-tailed test. We have alpha is 0.05, n equals 5, and find your critical score. Now, the critical score you should have found is an R crit of 0.8783. Now, because this is a two-tailed test, it's non-directional, that is going to go on both sides. So we have a negative and a positive version of it. Now, does our R score go past either of these scores? It in fact does not. Negative 0.808 does not go past negative 0.8783. So because it does not go past it, it is before the crit score, we know that it has a probability greater than 0.05. So assuming the null is true, assuming that there is no relationship between candy consumption and childhood depression, this was a likely finding for us to find. This is a likely sample for us to gain. So that's evidence in favor of the null. So we decide not to reject the null, and the null becomes our conclusion. So all you do is just restate the null hypothesis. There is no significant relationship between candy consumption and childhood depression. And then all you have to do is just put this back into the general language of the general question for that final conclusion. Candy consumption is not related to childhood depression. Now, lastly, I want to show you what the scatter plot would look for this data. You can see that the dots are somewhat close together. So again, that represents that 0.65 kind of strength of the relationship, or the 0.80. They're moving in a downward trajectory from the left. So that's indicating the negative relationship there. So this scatter plot is visually showing us what we've seen with the numbers that we have here. Okay. And that is how you do a correlation in the context of hypothesis testing.